Hello, welcome to Chapter 8, Homework Questions 29 through 34. Question 29. At 3:25 p.m., two trains left Kalamazoo, Michigan. One traveled westward at a constant rate of 82 miles per hour, while the other traveled eastward at a constant rate of 66 miles per hour. If they are now 111 miles apart, what time is it now? Write and solve an equation or a system of equations to answer this question. So as we go through this, what are we looking for? What are the things that we don't know? We don't know the time traveled in terms of when they started and when they're now 111 miles apart. So let's do some let statements here. We will let x equal the time traveled. And this represents hours, so let's indicate that as well. And then we also need something to represent the distance between the two trains. So let y equal the distance between the two trains. And this is in miles. Now, for this particular example, we actually know the distance between the two trains. It tells us it's 111 miles apart. So we actually know what the y value is. So if you didn't write a let statement for y, that's perfectly fine as long as you know that we're going to use that distance between the two trains. So with the time traveled, the first train is at a constant rate of 82 miles per hour. So if I take 82 times the amount of time that it is traveling plus the 66 miles per hour for the eastward train, and that time it has traveled, that will give us the distance for each of the trains, and since we're adding them up, it gives us the total distance, which is your y value, or 111. And so now you can see that you can add the two expressions, set them equal to 111, and then divide. So it looks like we get 148x is equal to 111. Divide by 148, and we get 0.75. And remember, this is in hours. So since it's not a whole number, 0.75, that's, you have 60 minutes in an hour, okay? And that's 3/4 or 0.75. So if you take 60 minutes times 0.75, that will give you what that percent is of 60 minutes, which would be 45 minutes. Now you didn't have to do it that way because it's 3/4 of 60. If you break 60 up into 4 parts, it'd be 15, 30, 45. So however you want to look at that, but we do want to break it down into minutes because we want to answer the question as to what time are they 111 miles apart. So at 3:25 p.m. they started. 45 minutes in, they are 111 miles apart. So 35 minutes would give us 4 o'clock. So I'm actually going to break this up. And there's a couple ways you could do this, but if I break this up into 35 minutes, the reason being that 35 minutes will actually put us at 4 o'clock. And then I have the additional 10 minutes that I need to add to that, which would be at 4:10. So at 4:10 p.m., the trains will be 111 miles apart. And make sure you answer the question. Anytime it asks the question, you need to kind of restate it and answer it as well. And make sure you label it. Question 30. Remember that a square is a rectangle with 4 equal sides. Part A. If a square has an area of 81 square units, how long is each side? Well, each of these sides must be the same number. So what times what gives you 81? And that would be 9. So this would be 9 units. And we once again want to make sure we are labeling. Is 9 units each side of the square. All right, part B. Find the length of the side of the square with an area of 225. So 225. So what times what gives yourself 225? You might know that. You could also set up an equation for these types of problems. X squared is equal to 225, and then you can take the square root of each side. So x is equal to 15. So this one will be 15 units each side of the square. Part C, Find the length of the side of a square with an area of 10 square units. So this one's 10. Now, when you think about this one, you're not going to know an exact value that multiplies each side to give you 10. So especially on this one, when you set up your equation, x times x is equal to 10, and then when you take the square root, x is equal to the square root of 10. That's the exact answer. If we would want an approximation, you'd plug it into your calculator. I'm going to round to 2 places, and that's approximately 3.16. So it doesn't say round or anything, so I'm going to leave it as the square root of 10, but approximately 3.16 would be each side length. And next is D. Find the area of a square with side 11. Now be careful because it changed the question. It says find the area of a square with sides 11. So now we know the length and the width, and 11 times 11 is 121. So the area of that square is 121. We need units, and since it doesn't say what it is, we have to use units squared. Or you can say what they said, which was square units. It's the same thing. Question 31. Factor the following quadratic expressions if possible. Parts A through C are trinomials, while D is a binomial. Yet they are all quadratics. What makes each of them a quadratic? So we'll talk about part E in just a second. But on A through D, we are going to set these up with our generic rectangle first, knowing that k squared and 20, which is your ones, are across from each other. And then we have to figure out, remember using Casey's pattern again, is that 20 times k squared, that diagonal product, all right, has to be the same. We also know, sorry, it doesn't have to be the same, but we know we have negative 12k tiles in the other two boxes, so we know that they have to add up to negative 12k. So what are factors of 20? 1 and 20, 2 and 10, 4 and 5, that are going to work for the 12. Now, it is a positive 20 when we multiply, but when we go to add, it's negative. So that means our factors both have to be negative. So it looks like negative 2k and negative 10k would be the ones that we would be using right here. So we'll put those in, negative 10k and negative 2k. Now we can figure out this is k times k, which makes this a negative 2 and this a negative 10. So this is equal to k minus 10 times k minus 2. And there you go. On to B. 6x squared and minus 14. So on this one, do the same thing. We've got to figure out what the diagonal product is. So 6 times 14 would be, let's see, 60 and 24 would be 84. So minus 84x squared, and that has to add up to 17x. So look at your factors of 84. It is a negative 84, so we do know one's positive and one is negative. Let's see what we come up with. So I looked at the factors. 4 and 21, because it is a negative 4, one of those has to be negative, and the negative 4x and 21x, that adds to give you 17, but multiplies to give you negative 84. So it looks like we found them. Put them back in your generic rectangle in either of the spots. And then now we can work backwards here. We have 6x squared, so I need to make sure that it also goes into the 4x here. So I'm going to do a 2x and a 3x, and then kind of work my way from there. 2x times negative 2 would be negative 4x, and 3x times 7 would be 21x, and then my 7 times negative 2 gives me negative 14 as a check. So it looks like my answer would be 2x plus 7 and 3x minus 2. All right, on to example C. X squared minus 8x plus 16. And we need to set up our generic rectangle here, knowing that we have a x squared and a positive 16 for my ones. And we need to know what multiplies to give us 16x squared, but adds to give you negative 8x. And we got 1 and 16, 2 and 8, and 4 and 4. So it looks like the negative 4 and the negative 4 would multiply to give you a positive, but add to give you negative 8. So we'll put those in the generic rectangle, and we know x times x is x squared, x times negative 4 is negative 4x, and same thing on both sides. So it looks like we will get x minus 4 times x minus 4, and I'm just going to write that as x minus 4 quantity squared. All right, on to D. 9m squared minus 1, so we have 9m squared, and then minus 1. Our middle term is missing, so we know the product has to give us 9m squared, actually negative 9m squared, but the middle term, we don't have any tiles, so it's 0m. So what multiplies to give you negative 9, but adds to give you 0? They have to be opposite numbers, so it would be negative 3 and positive 3. So I'll put those in the generic rectangle. That means that 9m squared would have to be 3m times 3m. 3m times 1 gives you 3m, and then 3m times negative 1 gives you negative 3m. So it looks like the answer will be 3m minus 1 and 3m plus 1. And look how your binomials are the same except the signs. And then now this gets us to part E, that wants us to know what makes each of them a quadratic. And because the largest exponent in each of these is a 2, that's what makes it a quadratic. And there you go, that finishes off question 31. Question 32. Change each expression into radical form and then give the value. No calculator should be necessary. So let's see what we can get here. On A, we have 125 raised to the 2/3. So remember, when we are dealing with rational exponents, if it's 1/2, that represents the square root. If it's 1/3, that represents the cube root. And remember, this technically is a 2 in the square root. If it's 1/4, it is the 4th root, and so on. So if we can rewrite 125 raised to the 1/3 instead of the 2/3, but then that has to get raised to the second. So 2 times 1/3 is 2/3. Now you can rewrite it as a radical. That would be the cube root of 125 and then squared. So what's the cube root of 125? 5, because 5 times 5 times 5 is 125, and then raised to the second power is 25. So we rewrote it as a radical, and we also found the value. On B, you have 16 to the 1/2. Now this one's a little bit nicer because it is 1/2, so we can just rewrite this as the square root of 16, which is equal to 4. On part C, we have 16, but now it's to the negative 1/2. So remember, negative exponents we can rewrite as the reciprocal of 16, which is 1/16, but now it's raised to the positive 1/2. So that's 1 over the square root of 16, which is 1/4. And then D, 1 over 81 raised to the 1/4. So that will be the 4th root of the fraction 1 over 81. So what times itself 4 times? You can also do the 4th root of 1 and the 4th root of 81. The 4th root of 1 would be 1, because 1 times 1 times 1 times 1 is 4. And then the 4th root of 81 is 3. 3 to the 4th power is 81. So we rewrote them as radicals, and then we also gave the value. Question 33. Solve each equation below for x. So we got a lot of different ones we're going to look at. Some of these we've been doing since the beginning of the year. Some of them are new. 2x equals 10. 2x minus 10 equals 0. So this is just a linear equation, one variable. We're going to solve for x by adding 10, dividing by 2. X is equal to 5. It does say check your solution. I'm not going to check my solution on this video, but to check it, you can just plug it back in and make sure it works. On B, you have x plus 6 equals 0. So we're just going to subtract 6 and get x equals negative 6. Then we're moving on to C. C, we have 2x minus 10 times x plus 6 is equal to 0. So you can see all of these are equal to 0. If we're setting them equal to 0, but now this one's a product. So this is like taking some number A times some number B and setting it equal to 0. Well, when we do that, what do we know? Well, one of them has to be 0. Either the A has to be 0 or the B has to be 0 when you multiply to get 0. So take that into account. How could I do this? Well, if that's the case, then the 2x minus 10, if that was equal to 0, that would work. Or the x plus 6 is equal to 0. And if we solve each of these equations, I'll show you that this works. Divide by 2, and then on this one, you're just subtracting the 6. And you can see, if you were paying attention, that the 2 I have, the 2x minus 10 and the x plus 6, those were the first two problems that we had on A and B. And so when we got x equals 5, we get x equals 5. When we got x equals negative 6, we got x equals negative 6. Now, why does this work? Well, what happens if I plug 5 back in 2? So I want to check to see that this is working. So I'm going to say 2 times 5 minus 10 times the quantity 5 plus 6. So I'm just replacing the x's and plugging it in. I get 10 minus 10, that's 0. And then I get 5 plus 6 is 11. Well, now that you have 0, 0 times 11 is 0. So that works. And then also, I'll plug in x equals negative 6. So 2 times negative 6 minus 10 times negative 6 plus 6. So now instead of getting 0 on the first set of factors, you get 0 on the second. But once again, it doesn't matter because 0 times anything is 0. So I wanted to show the check on that one because that one is a new one, where we have two things that are being multiplied to give us 0. Question 34. Do the freshmen really have the largest backpacks, or is that just high school legend stuff? Delenn was able to weigh a random sample of student backpacks throughout the school year. She also recorded the number of quarters of high school completed by the student who owns the bag. Using spreadsheet software, Delenn found the following. So all this information is given to you. So you guys won't need your graphing calculators to complete these problems. The LSRL is given. There's your equation. You're given the correlation coefficient. You have your data over here to the right in your table. So quarters completed is X. And the backpack weight in pounds is Y. You also have your residual plot and your scatter plot. So let's go ahead and look at the questions. On part A, interpret the slope of the least squares regression line in context of this study. So your slope is negative 0.55. Now remember, slope is the change of y, which is the weight of the backpack, over the change of x, which is the quarters completed. So this is negative 0.55 over 1. So that's the quarters completed. And then this represents the negative 0.55 has to do with the pounds. So how would we write that? Down here I have the answers to the questions, so I didn't have to type them all back up. But here's part A. On average, student backpacks get 0.55 pounds lighter. That's what the negative represents. You have to include that. Don't put negative, but explain it in terms of that. So pounds lighter with each quarter, so for every 1 quarter of high school completed. You need to have both parts there, and you also need to include the number. On B, it says calculate and interpret R squared in context. So R is given to you as negative 0.66. If you square the R value, you will get 0.4356, which is about 44%. So to interpret the R squared value, about 44% of the variation in student backpack weight, so that represents your Y, or your dependent variable, can be explained by a linear relationship with the length of time spent in the high school, which is your independent variable or your X value. Okay, part C. What is the residual with the greatest magnitude and what point does it belong to? So the residual plot is given to you over here on the right, so you are given that. You didn't have to find it. And it wants us to find what is the residual with the greatest magnitude and what point does it belong to. So which point is the farthest away from the line, from the residual line here. So take a look, see if you can figure out which one is the furthest away. The lowest we have on the graph is -7, and the highest is 7. So what do you think? This one right here? All right. And so go back and look at your table. That's at x equals 3. So what do we have here? And so we're trying to find the largest, the greatest magnitude, or the largest residual. So this point was x equals 3. That looks to be this one right up here in your table. All right, now that's the actual. We need the predicted, so we have to find that. So to find the predicted, we're going to use the equation. Y equals 13.84 minus 0.55. And then if we plug 3 in, what is the predicted weight using your line of regression? So y is equal to, we get a value of 12.19. And so we want to take the actual minus the predicted. So 12.19 minus the predicted, the actual minus the predicted. And you will get negative 6.23. Now, rereading the problem, it does say the greatest magnitude, so the negative doesn't matter in this case. And so 6.23, in the answer key, it did round. The largest residual value is about 6.2 pounds. And it belongs to the student who has completed 3/4 of high school. So they rounded to 6.2. I got 6.23, but either way, it's fine. Make sure you do include pounds, though. On to D. Using the least squared regression line model, estimate the weight of a backpack for a student who has completed 10/4 of high school. Use the appropriate precision in your answer. So you can see down here, 13.84 minus 0.55 times 10. This represents the number of quarters of high school, and you can see that when you did that, you get 8.34 pounds. So that's how you make that prediction. And then part E, it says, is a linear model the best choice for predicting backpack weight in this study? Support your answer. Well, look at your residual plot over here. Do you feel like it has a pattern, or do you think it is scattered? And so when you look at it, it does look a little scattered. It does look a little scattered, but it also looks like it might have a curve here a little bit. So in the answer, it says a different model would be better because it looks like there is a curve pattern in the residual plot. So there you go. There is question 34. And once again, this is one that you can do without the calculator. It has all the information on there for you.